Welcome to our channel. Today, we're diving into the incredible mind of Isaac Newton and exploring his most groundbreaking accomplishments. You know, when you think about it, it's pretty amazing. We've got this whole universe, right? Stars exploding, galaxies colliding, black holes doing their black hole thing. And yet, somehow, we humans, with our relatively limited senses, have managed to figure out some of its deepest secrets. And when it comes to unlocking those cosmic mysteries, few minds shine as brightly as Isaac Newton's. So, buckle up, fellow stargazers, as we embark on an exhilarating journey through the life and times of a true scientific revolutionary. Let's start with the basics, the fundamental laws that govern the motion of objects. Newton's laws of motion. Before Newton, people had a hard time understanding why things moved the way they did. But Newton, he cracked the code. His first law, the law of inertia, states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. This means that if something is moving, it won't just randomly stop, and if it's still, it won't just magically start moving. There has to be a reason, a force acting upon it. His second law explains how force is related to mass and acceleration. Basically, the more massive an object is, the more force you need to accelerate it. It's like trying to push a car versus a shopping cart. You need a lot more oomph to get that car moving. And finally, his third law, the one we all know and love. For every action, there is an equal and opposite reaction. This law explains everything from rockets launching into space to the simple act of walking. Now let's talk about gravity. Legend has it that Newton discovered gravity when an apple fell on his head. While the story of the apple is probably apocryphal, what we do know is that Newton's insight revolutionized our understanding of the universe. He realized that every object in the universe attracts every other object with a force that is proportional to their masses and inversely proportional to the square of the distance between their centers. In simpler terms, the bigger and closer objects are, the stronger their gravitational pull. This explained why the apple fell from the tree, why the moon orbits the Earth, and why the Earth orbits the Sun. It was a profound realization that unified the heavens and the Earth under one elegant law. Before Newton, people thought that the laws governing the cosmos were separate from those on Earth. But Newton showed that the same force responsible for an apple falling to the ground also keeps the moon in orbit around the Earth. It was a revolutionary concept that shifted our entire worldview. Now imagine trying to describe the motion of the planets or the changing tides without the right mathematical tools. That's where calculus comes in, a branch of mathematics that Newton essentially invented. He developed calculus to solve problems related to his work in physics and astronomy. Calculus is a way of describing change and motion, and it's essential for understanding everything from the orbits of planets to the flow of fluids to the behavior of light. Before calculus, mathematicians struggled to describe continuous change. They could only work with static snapshots of the universe, but calculus gave them the tools to describe how things change over time, allowing them to model complex phenomena like the motion of planets and the flow of heat. It's no exaggeration to say that calculus revolutionized mathematics and science, paving the way for countless discoveries and advancements. Now let's shed some light on another one of Newton's groundbreaking achievements, his work in optics. Newton was fascinated by light and color, and he conducted a series of experiments to understand their nature. One of his most famous experiments involved shining a beam of sunlight through a prism. What he discovered revolutionized our understanding of light itself. The prism separated the sunlight into a spectrum of colors, proving that white light is actually a mixture of all the colors of the rainbow. This discovery challenged the prevailing belief that colors were modifications of white light. Newton didn't stop there. He also explored the nature of light itself. At the time, there were two competing theories about light. The wave theory, which proposed that light traveled in waves like ripples on a pond, and the particle theory, which suggested that light was made up of tiny particles. Newton's experiments led him to favor the particle theory, which he called the corpuscular theory of light. While we now know that light behaves as both a wave and a particle, Newton's work laid the foundation for our modern understanding of this fundamental phenomenon. And speaking of light, Newton's work in optics led him to invent the reflecting telescope, a revolutionary tool that transformed astronomy. Before Newton, astronomers relied on refracting telescopes, which used lenses to bend and focus light. However, these telescopes suffered from a major drawback: chromatic aberration or color distortion. Newton's brilliant solution was to use a curved mirror instead of a lens to focus light. His reflecting telescope was smaller, more powerful, and produced clearer images than traditional refracting telescopes. This invention revolutionized astronomy, allowing astronomers to see farther into space and make more accurate observations. The reflecting telescope wasn't just a scientific breakthrough, it was a testament to Newton's ingenuity and his ability to see beyond the limitations of existing technology. His invention paved the way for the powerful telescopes we have today, which continue to unlock the secrets of the universe. And think about it, the next time you see stunning images from the Hubble Space Telescope or marvel at the discoveries made by astronomers peering into the depths of space, remember that it all started with Newton and his revolutionary reflecting telescope. Thanks for watching. If you enjoyed learning about Isaac Newton's incredible contributions to science, don't forget to like, subscribe, and hit the bell icon for more fascinating content. See you next time. Newton's work laid the foundations for modern physics, astronomy, and mathematics. His laws of motion, his law of universal gravitation, his invention of calculus, and his groundbreaking work in optics, these achievements continue to shape our understanding of the universe. But perhaps even more importantly, Newton's life and work serve as a testament to the power of human curiosity, creativity, and the relentless pursuit of knowledge. He dared to question, to experiment, and to think differently, and in doing so, he unlocked some of the universe's most closely guarded secrets. So, the next time you look up at the stars, remember Isaac Newton, the genius who changed the world.